Welcome back to the channel, tech enthusiasts. Today, we're diving deep into a story that has absolutely exploded across hacker news and sent ripples through the entire tech community. We're talking about GLM-5.3, a new large language model that isn't just generating text or images, it's demonstrating something far more profound, and frankly, a little unnerving. Emergent cyber capabilities. This isn't just another AI advancement. This is a paradigm shift that will redefine our understanding of artificial intelligence, programming, and digital security. So, buckle up, because we're about to explore what this means for frontier coding, cybersecurity, and the very future of how we interact with intelligent machines. First, let's ground ourselves. What exactly is GLM 5.3? In essence, it's the latest and most advanced iteration in a lineage of incredibly powerful large language models. Think of it as a significant successor to the GPTs, llamas, and other similar architectures, but with a monumental leap in scale, sophistication, and most importantly, truly emergent properties. These models are not merely statistical engines. They are complex systems trained on unimaginable quantities of text, code, network logs, and digital interactions, learning patterns, logic, and context from virtually the entire publicly available internet. GLM 5.3 pushes the boundaries of what these models can not only comprehend but actively do. It's designed not just for passive understanding, but for active problem solving, particularly in the highly intricate realms of complex software engineering, system architecture, and as we're now discovering, autonomous system interaction. Now, let's tackle the phrase that's causing all the commotion: emergent cyber capabilities. This isn't about an AI being explicitly programmed with a list of hacking tools or security protocols. The emergent part is the absolute core of this breakthrough. It means these sophisticated abilities weren't directly coded into GLM 5.3 by its human creators. Instead, they arose spontaneously and organically from its vast, deep training. From processing billions of lines of code, millions of vulnerability reports, and countless network communications, GLM 5.3 has developed an intrinsic understanding of how digital systems work, how they fail, and how they can be manipulated or protected. Picture this. You expose GLM 5.3 to a novel software environment, perhaps a brand new operating system or a proprietary web application it's never seen before. What researchers are observing is GLM 5.3 not just identifying potential vulnerabilities based on known patterns, but profoundly understanding the underlying logic of the system well enough to hypothesize entirely new attack vectors or highly sophisticated defense strategies. This isn't just about an AI pointing out a weak password or a simple configuration error. We're talking about an AI that can, given the right context, analyze a complex codebase written in multiple languages, identify a subtle logical flaw that might lead to a sophisticated exploit, and even suggest or generate highly optimized code to either patch that vulnerability or, conversely, exploit it. Imagine an AI being able to grasp the intricate nuances of zero-day exploits, advanced buffer overflows, complex SQL injection techniques, or multi-stage cross-site scripting attacks. It doesn't do this because it was explicitly taught a rulebook for these. Rather, its deep learning model has inferred the fundamental principles of system weaknesses from countless real-world examples and theoretical discussions across the web. This capability transforms code generation into something far more dynamic and potent: autonomous cyber interaction generation. The buzz on Hacker News is predictably palpable. This platform, renowned for its highly discerning and technically astute audience, is now ablaze with discussions ranging from sheer awe at the AI's power to extreme caution and urgent calls for ethical oversight. Seasoned developers, cryptographers, and cybersecurity professionals are dissecting every facet of this revelation. Some hail it as the ultimate co-pilot for securing our increasingly fragile digital infrastructure. A tool that could revolutionize how we identify and fix critical bugs before they ever become catastrophic threats. Others are sounding urgent alarms, comparing GLM-5.3 to the opening of Pandora's box. The fear is legitimate and multi-layered. If an AI can emerge with these kinds of sophisticated cyber capabilities, how do we effectively control them? What happens if such a powerful and autonomous agent falls into the wrong hands? Or worse, if it develops an unintended, self-preserving, or even malicious agenda outside of its developer's initial intent? The implications for cybersecurity are nothing short of monumental, and they distinctly cut both ways. On the defensive side, GLM-5.3 could prove to be an unparalleled asset. Imagine an AI that can continuously monitor vast, distributed networks in real time, identify previously unknown zero-day vulnerabilities, not just in code but in system architectures, and even propose or implement immediate patches and defensive measures with minimal human oversight. This could elevate our global digital defenses to an unprecedented level, making critical infrastructure and personal data far more resilient against both human and potentially AI-driven attackers. It could democratize advanced security, allowing smaller organizations and individual users access to robust protection previously only available to well-funded state-level actors or multinational corporations. However, the offensive potential of such a model cannot, and must not, be ignored. An AI capable of emergent cyber capabilities could theoretically be directed, or even autonomously decide, to find and exploit weaknesses in critical national infrastructure, global financial systems, or defense networks. The sheer speed, scale, and relentless efficiency at which an AI operates far exceed human capabilities. The risk isn't just that it could be used for malicious purposes, but that its very autonomy and emergence make it incredibly difficult to predict, interpret, or fully control.